geometry. We start our unit on circles, which is CO59. And there's so much more circles that I promise you ever thought existed. We're going to learn about all the definitions, all the terms that have to do with circles. We're going to learn about the different properties and characteristics. We're going to graph circles on the coordinate plane. So much to do with circles. It's like the unit will never end. Okay. We'll start with something that you should know. Damien, what is a radius?
Radius is half or the across the length of a circle.
Okay. It is a segment.
Yes.
From the center to a point on the circle. Okay. A radius is a segment going from the center of a circle to a point on the circle. If you've got room to draw a picture, if you want to, feel free. But a radius, okay, from the center to a point that's on the circle. Okay. A chord. Anyone know what a chord of a circle is?
Like the distance around it.
That's the circumference.
Circumference, good try.
Okay. A chord in a circle is a segment that's from one point on a circle to another point on the circle. A chord is a segment from one point on a circle to another point on the circle. So example of a chord?
So basically a radius.
Nope. A chord starts on a point on the circle and goes to another point on the circle.
Wait, on the outside of the circle?
When we say a point on the circle, it is on the outside. Inside doesn't really. It is considered the outside of a circle. Yes. Okay.
So the diameter is a chord.
Yes, very good. So the diameter is a very special kind of chord. The diameter is a chord that specifically what? Passes through the center. Okay. The diameter is a chord that passes through the center.
What?
The diameter is a chord that passes through the center of a circle. So when you first learned about circles growing up, you learned about the diameter and the radius. We use those measurements, radius in particular, with area and surface area and volume of spheres and all that sort of stuff there. But the diameter is that it's a very special chord. Right? It starts on a point on the circle, and it goes to another point on the circle, but it does pass through the center. And the relationship between the diameter and the radius is half of whatever the diameter is. Okay? The diameter is also what gives us that relationship to pi. The circumference, which someone brought up earlier, the formula for circumference of a circle, one way to find it is pi times d. Okay? The distance around any circle is always pi times the diameter.
Yeah.
Right? So to come up with a good estimation, measure the distance across a circle and then multiply it by about 3. Right? And that's going to give you an estimation of that circumference. Question so far? Because I'm going to erase this and scroll on down so we can get it.
Oh, no, you're totally good.
I appreciate it. All right. Secant. What is a secant?
Is that called second?
A secant is a line, and I really should say segment ray line, just to use that before. A segment ray or line that passes through a circle. So unlike a chord, that must be a segment because its endpoints are on the circle, a secant is a segment ray or line that passes directly through. Such as that. It does not. Anything that goes through the middle should be marked, and you'll know if something goes through the center if there's a dot on it in the center of the circle. But this is a secant. This could be a secant here, okay? Anything that passes through. Tangents, which is a little confusing because we already have a tangent definition with triangles. The tangent of a circle is a segment, ray, or line. Damien, what are you looking for?
I was looking for twins.
I can get you some. A tangent is a segment, ray, or line that touches a circle exactly once. Here they are. A segment, ray, line that touches a circle exactly once. A segment, ray, or line that touches a circle exactly once. So we've got a circle here. A tangent line would come through like this, okay, and touch just one point on the outside of a circle, or touch one point on the circle.
Can you start it?
No, a tangent line is entirely on the outside of a circle, except for that's a good point. Alex asked, Alex asked, could you have a tangent that starts inside the circle and goes out and touches it exactly once? No. Okay, a tangent is entirely on the outside of a circle, except for that one point.
Otherwise, it touches
touches.
twice.
Okay, what's that?
It would touch twice.
Well, not if it started. If it was a ray.
Yeah, but if you had to go through it, then it would touch twice.
Right, that would cover the secant.
Yeah.
Yeah. So this would not be. This is not tangential.
Haha.
Yes.
So you probably just correct myself. But a ray can't be started in the center, right?
Sorry, say again.
A ray can't be started in the center.
A ray can be starting wherever it wants to. I'm just saying that it's not a tangent if it starts in the inside the circle, goes out through the circle. Because technically, this does only touch the circle once, right? But it's not a tangent line. A tangent line is entirely on the outside of the circle, except for that one point on the circle that it passes through. Yes.
Shouldn't that be in the definition then?
I only have 2 lines. Sure, add it. Yes, please. Tangent on the outside of a circle. A tangent is on the outside of a circle. There you are. Point of tangency is the point on a circle. The tangent line touches. So the point of tangency is that special point, that one point that tangent line touches. That is the point of tangency.
Circle, but target. Can I say tangent?
The point on a circle the tangent line touches is the point of tangency.
So then, is it like completely different? Like, I mean, is a triangle tangent?
Yes, it's not anything like the sine, cosine, tangent, triangle stuff that we've covered. A circle tangent. I don't know why it's the same name. I didn't name
Yeah,
it.
for real.
No, but
Maybe you should.
Wait, for what?
well, there's more than one element in the world, so there can be more than one tangent.
No, they're
I like that.
not even that.
And final definition: common tangents. A segment ray line that is a tangent to multiple circles. A common tangent is a segment ray line that is tangent to multiple circles. So for example, I'm going to draw my tangent line first because otherwise it's hard to get these to line up here. But if you have a line coming through here that's tangent to this circle, pretend that touches. There you go. Tangent to that circle. That is a common tangent. It is a tangent line to more than one circle. Okay.
Wow.
And there are 2 theorems that have to do with tangents. Theorem 10.1 tells us this. Can I scroll up? Are we all good? I'll let you pick up.
Go ahead.
Yeah.
Did you come up with theorem 10.1 or did you like, or is that like
No, it's a real thing. I looked it up when I couldn't find
like
it.
10.1? That's like
So the reason why it's called 10.1 is it's the first theorem in the 10th chapter of the book. These names are arbitrary unless it's like the right angles congruence theorem, right? The theorem 10.1, it just has to do with tangent. There is no fancy name for it. It's only called that because it's the first
I got
theorem in chapter 10. And it's kind of an arbitrary name. Anyone else need the notes?
No.
I think we're good.
Rowan, you can watch the video. Don't forget to like and subscribe. Theorem 10.1 says that a tangent line is perpendicular to the radius. A tangent line, if it is a tangent, must be perpendicular to the radius. So you've got a circle here.
I feel like I'm not learning anything right now. With the theorems.
Yep. That's kind of what a lot of geometry is.
I don't know what to do though right now. Like,
Right now,
how
just
to solve it.
take down the solving comes in the application. See, the theorems are the
Just write down
relationships.
what's
The
right
application is the solving, right?
Oh, okay.
So here's our tangent line. Here's our point of tangency. Okay? The radius of the circle is perpendicular
That seems like a lot.
to the tangent line. And of course, whenever you've got a right angle, you open the door for things like right triangles. You'll see on the next page, you've got some right triangles.
Oh
No.
Wait, no, we're just gonna have to get a list of it, like just figure out. That seems like math factory.
It is very math packed, yes.
No,
That's very true.
I never even knew that thing.
Theorem 10.2 says that tangents with a common external point, remember external means on the outside, okay, are congruent. Tangents with a common external point are congruent. So there's our circle. Here are two tangents with a common external point. Okay? Tangents with a common external point. We know that these are congruent segments. Okay? Catherine,
It looks like the sign.
Can you give me the definition for
congruent means the same. So their lengths would be the same.
Some people just forget,
Dan. Albert Einstein of the day.
Yep, Mr. Olson gave it to me.
That's a. So you said something really smart.
Yes,
No,
questions.
I was asking really good questions, and they gave me the Albert Einstein of the day, and so now it's a thing. So if you get Albert Einstein of the day, and somebody's like talking to you, and they don't deserve to be talking to you because you're Albert Einstein of the day, you just go like that.
All right, thank you. Okay. Yes, Aiden.
Could there be more than one radius? How does the perpendicular one work?
So, yes, there could be. You could have a radius that comes up here, okay? But if our tangent line is here, okay, we know that there's another tangent line that comes through here that is perpendicular to that one. Right, yes, there's an infinite number of radii, there's an infinite number of tangent lines that could be drawn, but the relationship between the tangent and the radius is that they form a 90-degree angle. Okay? Alright, this is the information part of the thing, okay? Kylie, I need you focused. Right, Alex? Okay. The next page is the application. The next page is the practice of what the terms are and the application of particularly these theorems here. So for the next 10 minutes or so, I'd like you to work on this.
We don't know how to do it yet, though.
Okay,
15 minutes left.
Oh, actually, I do know how to do it.
give yourself a chance. Be Albert Einstein, right?
Oh, yeah.
Label
Albert
the
Einstein
diameter, the
science
radius, the secant, tangent, chord, tangent. Look back at the definitions. Books, shh, not done yet. And then here, this is the application of the two theorems. The first one says, is segment DE tangent to circle C? And how do you know? First of all, this is the notation for a circle. Okay? Triangle is a little triangle. A circle is a circle with a dot in the middle, so you don't confuse with an O or with a 0. Okay? But is DE tangent to circle C? If something is tangent to a circle, what must be true? Must be a right
It's
triangle.
not, though. It's not.
Okay? So basically, the application of that theorem is this a right triangle? Yes or no, and how can you determine that?
Yes.
How?
Well, if you use sync tangent.
Well, to use sine cosine tangent, we would have to have an angle, which we don't here,
Oh.
right? So you can't use the right angle. You have to have
Pythagorean
one.
theorem.
Pythagorean theorem. Okay. So we've got one leg of 3,
Yep.
one leg of 4. What's the length of the hypotenuse?
4.
7.
4. That's the long.
7.
I've not heard the correct answer yet.
5, 6, 6.
Catherine, why is it 5?
Because 3 squared plus 4 squared square root that equals 5.
Okay, so if the hypotenuse is 5, Catherine, don't stop. Okay, if the hypotenuse is 5, it's a right triangle. But how can we determine? Remember, we're trying to figure out, is this a right triangle? How can we determine?
No, it's not.
But how can we determine if the hypotenuse is actually 5? The Pythagorean theorem says it should be 5. So is 6. 6 is bigger than the 2 legs. Ellen?
Because the other part of the line is a radius and it's the same as the
Yes. This hypotenuse is made up. This section of the hypotenuse is another radius of the circle, which means we know from here to here is 3 plus 2. This whole distance.
It's 5.
Therefore, it is a right triangle. Therefore, DE is a tangent line.
Yes.
We know this
How do you
has to
know
be
it's right,
3
though?
because this radius is marked as 3, and all radii have the same measure, and so that section must be 3. Okay? So we can determine that it is a right triangle because of the Pythagorean theorem, like Catherine said. 3 squared plus 4 squared does equal 5 squared, and we know the hypotenuse is 5 because of the 2 that's given to us. But that only refers to this section on the outside there. The intersection is 3 because it's a radius.
Wait, why does that make it a right triangle?
Well, because according to the Pythagorean theorem, 9 plus 16 equals 25, which is true.
Yeah.
Right?
Yeah.
So because these 3 side lengths fit the Pythagorean theorem, it means that it's a right triangle.
But 3 plus 4 doesn't equal 7.
No, it does. Well, yes, it
Oh,
does,
It
but
doesn't equal 5.
it doesn't have to. The Pythagorean theorem is not a plus b equals
It
c.
just has to be.
It's a squared plus b squared equals c squared. Right?
Oh, and they have to be less than 5.
What?
They have to be less than the.
The 2 legs have to be greater than the hypotenuse when you add them
Oh,
together.
yeah, that's what I was saying.
The sum
And
of
that
2
makes
sides
it a
must
right
be good.
angle.
We're on CO59
And that makes it a right angle.
because it works in the Pythagorean theorem. Yes.
Alright, sounds good.
Next one. ST is tangent to circle Q. Show how you can find the value of R. So in this case, we're told this is a right angle, which means we know we can use the Pythagorean theorem. We know the Pythagorean theorem is going to work. So the Pythagorean theorem, using our legs,
A squared
our legs are
plus
R.
18 squared.
Damien, I need you to stop there now.
Okay, sorry.
Our legs are R and 24. So we know that R squared plus 24 squared, what's going to represent the hypotenuse length here? Hold on, Sophie? R plus 18. And when you write that, make sure you put it in parentheses because you're squaring the entire side. You're squaring the sum of those two parts. Okay, Catherine, what was your question? Because you're told.
Oh my goodness.
If ST is tangent to circle Q, theorem 10.1 says that a tangent line and the radius make a right angle. Yes, Andrew.
I think it says it's 16.
Yeah.
Mine says
Yeah.
I think it was
Like
it's
a
a
16.
poor
Mine
copying.
says 18.
Yeah, it should be 18.
Don't ask me.
I'm sure the 16 is just it didn't copy up well.
I got
So change to 18. Right?
18.
And what's the proper way to simplify the right side of this expression here? Sorry?
R squared plus 18 squared.
Wouldn't that be swell if it was? This is, if you think back to last year, multiplying two binomials, it is mathematically illegal to distribute an exponent into parentheses when you have addition or subtraction. Instead, what's being squared is the r plus 18, and so you have to write it out as r plus 18 times itself, and that's where we bring in FOIL, crab claw, the
No
box
way you're
method,
doing
all those things
So r
from
squared
algebra.
plus
Okay?
18 squared,
If you forgot how to crab claw,
18r
Oh, I
squared.
forgot
I
about
use
the
RBF
claw.
r times r is r squared. R times 18 is 18r. Folks, shh. Joey, Rowan. 18 times r is another 18r. And 18 times 18,
18 plus 18.
oh, the middle terms? Yes. 18 times 18, though, is 396.
Oh, you're so 396.
324?
Oh,
Shoot, I guessed and I was wrong.
you sure did.
Whoopsie-doo.
Whoops, I made a mistake. That's on, but that's on.
Right?
Yeah.
What's 24 squared?
Can you do this song?
600, 500,
576.
576?
Easy.
We're squaring 24 because that's a leg of the right triangle. And the Pythagorean theorem says we should. So the good news here is that those r squareds, because we have one r squared on both sides of the equal sign, what happens to them? They cancel out. If they didn't cancel out, we'd be left using either factoring or the quadratic formula to solve, which you will need to do on the test. You need to know the quadratic formula for the test.
Good thing it's a CO.
Good thing I remembered that.
Yup, it's a seal.
There you go.
Let's go.
And so now we can move our 324 over. Give me that, folks. 576 and 324 is 242? 252?
So I just don't understand how you got the r squared.
Divide by 36. Then we get 7 is value for r. You don't understand how you got the r squared way up top?
No, I don't understand how you got that equation.
This one here?
Yeah.
So we're using, knowing that this is a right angle, we can use the Pythagorean theorem. Okay? Pythagorean theorem says that one leg squared, there's our r squared.
Oh yeah, I get it now. I get it.
24 squared. And the hypotenuse is two sections, so we had to add them together, r plus 18 squared. But we can't distribute that power because there's addition. Joey. Damien. Both of you. Need to.
Wait, what the hell come it's not r plus 18 squared plus r squared? Why wouldn't it be the height? It's a squared plus b squared equals c squared. Why is it?
So C is r plus 18. And then we square that sum. Right? Whatever r is added to 18, and that gets squared. Right? Lisa. Negative b plus or minus root b squared minus 4ac divided by 2a. It's okay. Yes.
Are we gonna do a practice on
We will, yes, before time comes. The last one, this deals with theorem 10.2, which says that the two tangents with a common external point, they're congruent.
Oh, yeah.
How do we know these are tangent lines? Because we only use theorem 10.2 if we know they're tangent. How do we know they're tangent lines? Kylie.
The radii are the same, perpendicular to the tangent.
Because of the right angles there. Okay, the radius of the tangent, you've got the right angles. Which means that x squared is congruent to 9.
That is, that's the right angle.
So we know that x squared is equal to 9. X is 3.
Plus or minus 3.
Thank you.
What?
When you root both sides, remember that you need to include that negative sign also. Okay? Because when you square negative 3, you get 9. When you square positive 3, you get 9. So you need to include them both. I heard the question, why are we rooting both sides? We're rooting both sides because we're PERMDAS people. Our quality of life is just better. What operation undoes an exponent? A root. That's why we have PERMDAS. Okay? The opposite of squaring something is rooting it. So when you solve for a variable with an exponent, to undo that, you would take the square root. What's that? Because the definition of a root, what times itself equals 9? Well, 3 times 3 equals 9. So does negative 3 times negative 3. And you need them both. Okay? All right. I thank you, those of you who stayed quiet and listened through all of it. I hope that it's making some pretty good sense. For those that are chatty and disruptive, well, it'll catch up with you. For homework for tomorrow.
No way.
Bro.
We have 2 minutes. You can't just let us. We have a bunch of stuff going on in ELA and everybody has a game.
Dude, we have our game. We have such a time.
I have 2 games.
On page
And math though. And ELA.
655.
We don't have a line for homework. Oh, never mind. It's on another page.
3 through 10.
Nuh-uh. What? Buddy, we have a light.
Oh, you fucking buddy?
Yeah.
And then on page 656,
No shot.
I'm not doing this.
18 through 26,
Yes, we're having another game tomorrow.
even. Work does need to be shown.
Oh, yeah, right.
This is page 656 here.
Wait, are they all even?
Is this extra credit? It's
No,
like a
3 through
summer
10
game.
is all of it. Otherwise, I wouldn't say 3. 18 through 26 even.
Ow.
Show work.
No.
Show